All right, so picking up with number seven. Number seven, we have some data regarding the monthly users in Snapchat after it kind of first launched. So Snapchat launched in September of 2012, and it caught on pretty quickly. 10 million people in the first month signed up, and it certainly has been increasing ever since. And in the beginning, especially, it was definitely growing exponentially. So for number one, or part A, I guess, in number seven, or just number seven, no part A, whatever. It says find the exponential model for the Snapchat data. Okay, so if you recall, exponential models, they take on the generic form of f of x equals that vertical intercept times your change factor, and then of course exponential, so power of x. So the vertical intercept we can see right here in the table is just 10. So I know my vertical intercept is going to be 10. So Snapchat as a function of months, I know the vertical intercept is going to be 10. But the change factor is not given to me. I have a table of data, yes, but I don't know the change factor. So we're going to have to calculate the change factor ourselves using that good old divide backwards trick, if you will, where we grab the latest data point, which is 60, divided by the earliest data point, which is 10. And this was over the course of 16 months. So all of this would get raised to the 1/16th power in order to know what that per month change factor is. So 60 over 10, 1/16th. So what do we got? We got 60 over 10 raised to the 1/16th. All right, so the monthly Snapchat change factor is about, let's go we'll go 118. So 1.118. So my change factor I now know is 1.118, and this will be exponential as the months go by. Okay, number seven, done. Number eight says, find the number of months it takes until those users are going to reach 100 million. So 100 million is definitely going to be an output value, which tells me that when I set this up, I want to put the 100 on the outside in the output position. So 100 as the output would be out here. Vertical intercept is 10. Monthly change factor is 1.118. How many months does it take? We don't know. Okay, and then we're just going to start solving. So you'll notice it kind of becomes like all the other problems. I'm going to divide by 10 just because I can. So 100 divided by 10 is 10. And so then I have 10 equals 1.118 to the power of m. And if you're feeling stuck right now, that's actually a good thing. It's because you've done everything you can and you're now stuck in a basic exponential form. 1.18 to what power makes 10? I have no idea, but a logarithm can solve that for you. So this is where you essentially are officially doing the inverse operation of the exponential, which is a logarithm. And so we know the desired result is 10, and the base, oh, I should have left room, hang on. The base of this exponential, therefore the base of the log, is 1.118, and the desired result is 10. And that computation right there will tell me what m is. Remember, in the exponential form, that exponent becomes the output in log form. So whatever this computation is my answer. And I know it looks weird, but that's just a value. So let's go ask Desmos. I need, scroll down to my log base. 1.118 was the base of the log, and the desired result was 10. So here we go, 20.64. It's going to take 20.64 months. 20.64 months, and specifically months after September of 2012, because that is what the input stood for, is months after September 2012. So using a logarithm, we can solve for that. Okay, last but not least on this one, finding the general inverse. Okay, so if we go all the way back to chapter one, your general inverse always starts by just rewriting the original formula, but I typically drop the function notation and I just use my capital S as my output value and I just rewrite the model exactly as it was. The only thing different is I dropped the function notation for just a moment so I don't confuse myself. Input M, output S. The model is the model. So when you invert the model, you're doing the same inverse operations as before. The only difference is you no longer have a number out here, but instead you're keeping it generic. So the same inverse operations as before, meaning if you want to solve for M, the first thing we can do is divide by 10. Except instead of literally dividing by 10, I'm just going to represent it as S over 10 equals the 1.118 to the power of M. Now, again, at this stage, you're like, well, how the heck do I solve for M? How do I get M by itself when it's an exponent? Well, yeah. So again, if you're feeling stuck, it's because that means you have bases, powers, and results. And to take the inverse of that, you're going to use a logarithm. So when you come down here again, the base is 1.18, the exponent is m, and the result is s over 10. Those are the three components. So if you officially take the inverse of that exponential, it would be a logarithm. And again, the base is the 1.118 of the result would be that s over 10, and the exponent goes on the outside. And if that looks weird, I mean, I can appreciate it because you're not like totally used to this yet. But guys, this is mission accomplished. Your inverse operation, or your inverse model, I should say. Remember how before the output was S? Well, now the input is S. Remember how before the input was M? Well, now notice M is on the outside. It's the output. So that's it. You've done it. S is now the input. M is now the output. It's on the outside all by itself. You've done everything you can. This is the inverted model. All right, so that's a wrap on the Snapchat problem. We'll come back to the next video for the backside.